Hello and welcome! In this lecture we're going to implement the A-star pathfinding algorithm following the theory that we covered in the last lecture. Okay, so here we are in our project. Now let's begin making it. So let's go into our scripts folder, create a new C# script, call this pathfinding. Now if you wanted, you could make this a regular C# class just like we did for the grid system. That could be useful if you needed to make multiple pathfinding systems. But here we're going to have just one, so let's leave it with mono behavior and let's make a game object to run it. So make a new game object, pathfinding. Let's attach the script, reset transform, and open. Now here let's first define our width, height, and cell size. So a private int for the width, then a private int for the height, and a private float for the cell size. So pretty much the exact same thing that we used on the level grid. We're going to use the exact same values in a bit. Then on awake, let's actually do exactly this. So let's create a new grid system. Over here on pathfinding, let's make a private void awake. And on awake, let's create a new grid system. And over here, we're going to need the grid object type. So this is why we refactored our grid system to work with generics. We're going to create a type to store all of the data that we need for pathfinding. So let's actually just comment this out so the code compiles. Then here in the editor, let's make a new C# script. For this one, let's call it the path node. This is going to be our grid object representing a single pathfinding node. And in this one, we do not have mono behavior. Instead, let's make a simple constructor. So public path node, and here let's receive a grid position to know where this object is located. So let's make a private grid position for the grid position, and then we set it. Now, like we did on our previous grid object, let's override toString because this is quite often useful. So on the path node, let's paste this, except we don't care about the unit, so let's just print out the grid position. Okay. Next up, the next thing that we need is the gcost, hcost, and fcost. So let's have all of these. Let's make them ints. So we have the gcost, we have a private int for the hcost, and finally an int for the fcost. Then finally, like we saw at the end of the algorithm, we're going to need to go back from when we found the final node. So that means that each node needs to have a reference to the previous node where it came from. So let's make a private of type path node. And we're going to call this came from path node. So this is going to store the reference of the path node that we came from in order to reach this path node. Again, remember how the algorithm works in the previous overview lecture. First we find our target point, and then we're going to walk back through all the nodes to get the path. So this is why we need to store this. Alright, so here we have all the data that we need in each grid position to handle our pathfinding. Now we can go back into the pathfinding script, and over here now we can do a new grid system. Let's use our path node, and then let's use the exact same values that we used on the level grid. So 10, 10, and a cell size of 2. Now we should ideally only write these values once, so we should probably only define them over here on the level grid, and then have the level grid initialize the pathfinding, but for now let's keep it just like this. So you have this, then we need the func in order to create the path node object. So let's receive, first we need to receive a grid system of type path node. Then we have the grid position. And finally this one is going to construct a new path node, and let's just pass in the grid position. Okay, so we have our grid system. Now let's just store it. So here, private for the grid system, and we create it here. Okay. Now the next thing that we are doing on the level grid over here is creating the debug objects. So let's do that as well, so we can easily look into the internals of each path node. So let's copy this function, and let's actually comment it out over here. So we only want to see the debug objects related to the pathfinding right now. So let's go into the pathfinding, and over here let's paste it. That means we need this prefab, so let's make it. So let's make a serialized field, private transform for this prefab. Okay. Now let's build this prefab in the editor. And instead of starting from scratch, let's actually start from the current prefab. So you've got the grid debug object. Let's duplicate this one and call it something else. So the pathfinding grid debug object. Then just make sure this is working. Let's go inside and just change it visually. So on the color, instead of white, let's put a different color. So maybe a yellow. We're doing this just to be able to be sure that we're instantiating this object, not the other one. Okay, so on the pathfinding, let's drag this reference for the grid debug object. And just like this, let's test and see if everything is working correctly. And before we test, we just need to change one thing on the grid debug objects. So on the pathfinding, we're calling the function to create the debug objects, okay? Then over here, we instantiate those objects. Except then here, like we saw when we convert this into generics, we still made this manual conversion into the grid object. Now this conversion is obviously going to fail now, since path node is not in any way related to grid object. So since the path node will not be able to be converted into grid object, this will actually return null. And then if we go on the set grid object function, over here this is essentially going to receive a null grid object. So when we try to do toString, it's going to be null. So for now, let's just comment this out and let's test. And yep, it is working. So here we do see all of our debug objects and we are instantiating the correct ones. And with this, we can essentially verify that our pathfinding grid is indeed being correctly instantiated. Okay, great. So far, so good. Now, another thing that we can do, now that we have made our grid work with generics, is we can make some unique debug grid objects. So for example, on this pathfinding grid debug object, let's do just like we saw in the overview. Let's add fields for the fcost, gcost, and hcost. And now we can actually reset the color back into white since we already verified that this is indeed the one being instantiated. So we have this one, this is the main one down the center. This is going to still say the position. So let's just rename this to grid position text. And on the font size, let's actually make this just a tiny bit smaller, so 2.5. Then let's create 3 more text objects. So 1, 2, 3. Let's make one for the hcost text, another one for the gcost text, and finally the fcost text. Let's just make all of them quite a bit smaller, so maybe 1.5. Let's put them in bold, and they're going to say some value like 32. And now let's just put them on the corners. So let's put, for example, the G, put up there on the top left corner. For the H, let's put it on the bottom right. And for the fcost, let's put it on the bottom left. Okay, that's the setup. Let's just verify that we positioned them correctly. So let's go back into scene view, and over here, let's drag a pathfinding grid debug object. Let's zoom in on it. Let's put it on the center of the grid, so 6, 0, 4. Just to be able to make sure that we see them correctly. So let's go inside. Let's move the hcost a bit more in there, the fcost a bit more in there, and this one also a bit more in there. Okay, so we have all of our nice text fields in our debug object. Let's just override, apply the changes back into the prefab. Okay, and let's delete this. Now let's make a script to run our custom grid debug object. So let's create a new C# script, call it the pathfinding grid debug object. And now here, instead of extending mono behavior, let's extend grid debug object. So this is going to extend the original debug object script. And in here, let's add fields for those new text objects. So a serialized field, private text mesh pro. So we need to add using TM pro. So text mesh pro. Again, this time we are working with world objects. So we use text mesh pro and not text mesh pro UGUI. Okay, so we have the gcost text. Then let's have the other one, so the hcost text and the fcost text. Then in order to set them, we need to essentially customize the behavior on the base grid debug object. So on this one, let's make 2 changes. First of all, on the grid object, instead of receiving a specific type of grid object, let's just receive a generic object. Now object, if you don't know, this is the default C# class for pretty much anything in C#. So you can cast pretty much any type onto object. So here if we use object, this is a really nice generic object type. And this will actually automatically work with the toString, so we can uncomment this. This should also work. And on the setGrid object, let's make this virtual. With it being virtual, we can now override this. And for the update, let's also make it protected virtual. Okay, so this is the generic base grid debug object class. So now on the pathfinding grid debug object, let's override that one. So first, let's override the setGrid object. So here we're going to receive an object. In this case, we already know that we're going to be using this with the path node object. So let's just store a private path node, and we're going to set the path node equals, and we simply take the grid object and we cast it down into path node. And let's also leave the base.setGridDebug object. We're going to leave this just so that this also runs. So this base class also stores the grid object, which is then used in the update. So we're also going to use base.update. So let's do here, let's override the update. We do base.update to essentially update the base text object. And then here we can do gcost.text and set the text and go into the path node and let's get the G cost. So we need to expose this. So let's do that. Onto the path node, let's make a public int get G cost. We just return the G cost. Then same thing for all the others. So the G, then we have the H, and finally the F. Okay, we have all three costs. So over here we get G cost dot toString. Then same thing for the others. So the H and the F. All right, so that's it. Finally, let's just go into the grid system. And over here, let us no longer cast this back into grid object. So just let it be whatever type this is. Okay, so basically what we did here is we extended a more specific script for a more specific grid debug object. And then we made the base class still have the setGrid object. So when we call this, when we call it on the Pathfinding Grid Debug object, it's going to call this function, which is going to cast it down into a path node and store it. And then it's also going to run the base. So the base grid debug object will still store the grid object. And then on every update, first going to run the base.update, which is going to update it based on the grid object.toString, which in this case for the path node, we made the toString return the grid position. Okay, so the center text object will still display the string, the grid position. And finally for the other ones, they will display the various costs. So as you can see, due to using generics, we can really make this super extendable. All we need to do is here in the editor, let's go inside the Pathfinding Grid Debug object. Instead of using that class, let's use our Pathfinding Grid Debug object. Let's pass in the same text mesh row for that one, then the one for the G cost, for the H cost, and for the F cost, and get rid of the other one. Okay, let's save this and let's test. And yep, there it is. So now we have our custom grid debug objects and all of them are working correctly. This is going to be super useful as we start implementing our pathfinding because we won't be able to see visually the internal values of each path node as the algorithm progresses. Alright, so here we created the pathfinding script and everything is set up to begin implementing the actual algorithm. So let's get to that in the next lecture.